Hello everyone, this is a second activity of class plus 2. Let's get started. Now activity number 2. The objective of activity is to verify the relation R in set L of all the line in the plane defined by L is related to M such that L is parallel to M is an equivalence relation. So in order to verify this relation, material required are colored sheet, pencil, Fevicol, and scale. The prerequisite knowledge is you know the definition of equivalence relation and you know the properties of parallel and perpendicular line. So now how to demonstrate? For the demonstration purpose, draw few lines, say L1, L2, L3, L4 and L8 on the colored sheet. Now you see the line L1 is perpendicular to L2, L3 and L4 and L6 and L7 are also perpendicular and L2 is parallel to L3. These two lines are parallel. L3 is parallel to L4 and L5 is parallel to L8. So for the given relation L is parallel to M, the following lines are related. L2 and L3 because these two are parallel. Similarly L3 and L4 and L5 and L8. Now we will verify the relation R in set of line L such that L is related to M, L is parallel to M is an equivalence relation. So in order to justify that this relation is equivalence, first of all we will take a reflexive part. Now you know if a relation R is reflexive, then A must be related with A. So every line should be parallel to itself. So you see a figure, take example of any line, say L1. This line L1 is parallel to itself. Yes. L5 is parallel to itself. Yes. So we can say every line is parallel to itself. So the relation R, L related to M, L is parallel to M is a equivalence, is a reflexive relation. Sorry. Now take an example of L2 and L3. If L2 is parallel to L3, can you say L3 is parallel to L2? Yes, we can say that L3 is also parallel to L2. So L2 is related to L3 means L3 is related to L2. Now take one more example. If L3 and L4 are parallel, these two lines are parallel. So L4 is also parallel to L3. Hence, if L3 is related to L4, similarly L4 is related to L3. Take one more example. If L5 and L8 are parallel, so L8 is also parallel to L5. Hence, we can say L5 is related to L8. Similarly, L8 is related to L5. So, if A is related with B, implies B is related with A in each of these cases. So, we can say the relation R is a symmetric relation. So it is a reflexive as well as symmetric relation. Now we will check for transitivity. Now we will check the transitivity part for these parallel lines. So let us take an example of L2 and L3. First of all, L2 is parallel to L3 and L3 is further parallel to L4. Can you say that L2 and L4 are parallel? See, yes, we can say that L2 and L4 are parallel. So L2 is related to L3, L3 is related to L4. This implies L2 is related with L4. Now let us take one more example. If L3, this is your L3 and L4 are parallel and L4 is parallel to L2, can you say that L3 and L2 are parallel? Yes, these two are also parallel. So we can say L3 is related to L4. Further, L4 is related to L2. This implies L3 and L2 are related. So the relation R is transitive because if A is related with B, B is related with C, by definition of transitivity, A is related to C, holds good for this. So this relation is transitive. Now, if the relation R is reflexive, symmetric and transitive, we can say the relation R is an equivalence relation. So, this activity is useful in understanding the concept of equivalence relation.